Hello dear students, in this lesson I'm going to talk about properties of rectangle and square. In the first part of this lesson I'm going to talk about the properties of rectangle. This is the rectangles, and the first property is opposite sides are congruent. It means the length of AB equal to the length of B of DC, or the length of AD is equal to the length of BC. After that, so AB equal to DC, line segment of AB equal to line segment DC, and then we can say AD, line segment of AD equal to line segment BC. Opposite sides are congruent. And then the second property is opposite sides are parallel. It means AB is parallel to DC and AD is parallel to BC. So we can say AD parallel to BC, or AB is parallel to DC. And then the diagonals bisect each other. This diagonals bisect each other. It means this diagonal, when we have a point, for example M, so MB is equal to MD and MA is equal to MC. After that, the diagonals are congruent. It means DB is equal to AC. They have the same length. So we can say AC equal to DB or BD. After that, we have this rectangle. ABCD is a rectangle. MD, the length of MD is 2.3. 2.3. Find the length of MA. We have to find the length of MA. So we can say this figure or this shape is rectangle, so the diagonals are congruent and the diagonals are bisect each other. It means MA equal to MC and MD equal to MB. So we can say MA equal to MD, MA equal to MD equal to 2.3 centimeter, because the diagonals bisect each other and the diagonals are congruent. BN is the midpoint of BC. Show that MN is the perpendicular bisector of BC. So in the first part of this example, we proved MB equal to MD equal to 2.3, and we can say MC equal to MA equal to 2.3. The diagonals are congruent and bisect each other. So we can say MB equal to MC, MB equal to MC, and then N is the midpoint of BC. This is BC, and we have a point here. This point is N. So NB equal to NC because N is midpoint. NB equal to NC. M and N lie on the perpendicular bisector of BC. This point is M and N are lie on the perpendicular bisector of BC. Lie on the perpendicular bisector of BC, line segment of BC. So we can say MN is the perpendicular bisector, is the perpendicular bisector of BC. And then one of the properties for rectangle, we have 4 right angles, but this diagonal not bisector for this angles. Always this angle or the big angle is 2 times the small angle. So if we have the value for the small angle, for example, if the small angle is 20, always the big angle is 2 times 20. In the second part of this lesson, we have the properties of square. In square, the diagonals are congruent. It means the diagonals have the same measure. After that, each diagonal is perpendicular bisector of the other. It means when these 2 diagonals bisect each others, create 4 right angles here. So we have 4 right angles because the diagonals are perpendicular bisector of the other. Each diagonal is bisector of the 2 angles that lie on its endpoint. It means in square we have 4 right angles and these diagonals bisect these angles. For example, always this angle is 45 and the second one is also 45. After that, we have this example. What type of triangle is MAD? MAD. What type of triangle is MAD? So this shape is square. So we can say ABCD is a square. And then AC equal to BD because the diagonals are congruent. So we can say AC equal to BD, and then half of AC equal to half of BD. It means MA equal to MC and MB equal to MD, and then MA equal to MB and MD equal to MC. So we can say half of 1 out of 2 AC equal to 1 out of 2 BD. So we can say MA equal to MD. So MAD is an isosceles triangle because MA equal to MD, so we can say MAD is an isosceles triangle. After that, because this shape is square, so we can say AC is perpendicular bisector of DB. AC is perpendicular bisector of BD. So measure of angle AMD, measure of angle AMD equal to 90 degree. So the triangle MAD is a right isosceles triangle. And then for B, find the measure of the angles of triangle MAD. So the measure of angle AMD equal to 90. We proved in the first part of this example. Prove it. And then the measure of M plus the measure of D plus the measure of A equal to 180. Measure of M, D, A equal to 180 because the sum of the measure of interior angle in triangle equal to 180. So the measure of M is 90 plus the measure of D we don't know, and the measure of K we don't have the value for K equal to 180. Because of these two angles always are congruent, because this triangle is isosceles triangle, the base of angles are congruent. So for the variable D and K we can use the same variable like that, 90 plus K because they have the same number, the same amount. So we have 90 plus 2K equal to 180. So we have to change the place of 90 to the right side. 2K equal to 180 minus 90. 2K equal to 90, and then you have to divide both sides by 2. So the value for K, or the measure of angle K is D and A is 45. So the measure of A is 45 and the measure of D is 45 and the measure of M is 90. After that we have this example, you have this figure. In this figure you have some information. MNPQ is a square. MNPQ is a square, and then NL is parallel to MP. For a MNLP is a parallelogram, you have to show that MNLP is a parallelogram. So we have to say, or we can say NNQP is a square. MNPQ is a square. So we can say MN is parallel to QP, and then we can say PL on the line PQ. PL on the line PQ. PL and PQ on the same lines, so we can say PL on the line PQ, and then we can say NM parallel to PL, and NM parallel to PL. After that, you can say MP is parallel to NL. MP is parallel to NL. So thus MNLP is a parallelogram. Because the opposite sides are parallel. For B, we have to show that PL equal to PN. PL equal to PN. So we can say NMPL or MNLP is a parallelogram. We proved in the first part of this example. So NM equal to PL, NM equal to PL, NM equal to PL, and then NMQP is a square. So we can say NM equal to PN, NM equal to PN, and PL equal to PN, PL equal to PN. And then for C, we have to show that NL equal to NQ, NL equal to NQ, this triangles. So we can say NMPL is a parallelogram. NMPL is a parallelogram. So NL equal to MP. Opposite sides are congruent, and then we can say NMQP is a square. So NP equal to NQ, and then in the end we can say NQ equal to NL. For D, we have to show that the measure of angle NLQ equal to 45. So in the triangle LNQ, and the measure of LNQ equal to 90. The measure of LNQ equal to 90, and the measure of LQN is 45, because we have 90, 45 and 45. The sum of their measure is 180, so it is 45. NQ is a perpendicular bisector of is a perpendicular bisector of MQP. NQ is a perpendicular bisector of MQP. Bisector of this angle MQP, so which is equal to 90 degree. So we can say the measure of NLQ, the angle of NLQ equal to 180 minus 90 plus 45. So 180 minus 135 is 45 degree.